Hello guys, let's talk about client-server authentication. So let's imagine you are building a financial application and users can do things like view their balances, their transaction history, maybe even do things like save and invest. But here's the thing. How do you ensure that only authenticated users can actually view these things? Or how do you ensure that users can only view their financial data, their transaction history, and not someone else's? Well, the very bad approach would be to think of something like, oh, for every request that the user is going to make, well, they will just send their user ID, which sounds simple, right? But it's also a huge no-no.
No.
That's a very huge security risk right there. Because users of your application and even hackers might do something like, oh, just start sending requests with different user ID and trying to see, okay, what information they can get, what they can access, and so on. Now, let's look at different authentication methods. We're going to look at how they work, their pros and their cons, and every other thing you need to know. And by the end of this video, you're going to know how to keep your app secure without losing any of your sanity. Without wasting much time, let's dive right in. The first authentication mechanism we're going to be looking at is basic authentication or basic auth. And now, how does this work? Well, users essentially log in with their credentials, which are sent in every request encoded in base 64. It's just like sending a secret note written in pencil. An example of the HTTP request looks something like this. And in the authorization header, we can have something like this, which is the basic header and then the login password in base 64. Well, let's look at the exact steps. Firstly, the user is going to enter their login and password and send to the client. And then credentials are going to be sent for every request in base 64 to the server. And the server is going to decode it and verify the credentials. And if it is valid, access is granted. Otherwise, access is denied. Very simple, right? Well, let's see a quick overview of how that actually works. Well, we have the client here, and the client logs in, send a request to the server, and then the server returns a success response. And then for every request or every endpoint or data in which the client wants to access, well, the client is going to make the request and is going to pass in the basic auth details as shown. The server is going to do all the necessary validation and going to send back a response to the client. Well, let's quickly take a look at the pros and cons. Well, firstly, it is super simple to implement and it is also very easy to understand. Though it is not very recommended, but at least it is better than nothing. Now, let's take a look at the cons. Well, firstly, the credentials are very decodable, and as a result, they are not very secure or private. I can just look at the request that is being sent, intercept it, and be able to get the user's details. So, this comes with a very huge security risk also, and there is no session management or revocation. So, let's say the server needs to end or manage a user's access, which is typically handled using session, where there is no way to do this. And the fourth disadvantage is low performance and high latency, because whenever the credentials are sent, well, the server has to make a request or a trip to the database and to verify if the credentials are valid. And this happens for every single request. Now, let's move on and look at digest authentication. Now, to overcome the shortcomings of the first authentication we looked at, which is the basic authentication, we have digest authentication. How does it work? Well, it's very simple. The credentials are hashed on the server before sending them to the client, which makes them harder to actually intercept and decode. Now, think of it as in the previous example, which is the basic auth, the server is just sending you a secret note, which is basically written in pencil. But now this is being upgraded to like an invisible ink. So when users look at it at first glance, they don't understand or see what exactly is there. A sample HTTP request looks something like this. Now let's look at the steps involved. Well, the user, as usual, enters their login and password, and then the credentials are hatched on the server before sending. And afterwards, for every request the client wants to make, well, that particular login hash that is sent to the client is sent on every request. And then the server decodes and verifies the credentials. If it is valid, access is granted. Otherwise, access is going to be denied. Now, an overview of that looks like this. The client sends a request to the server. Then the hash is sent back. For every request, that particular login hash is going to be sent back to the server. and then the server is going to send the appropriate response. And moving on to the pros and cons, well, the first pro is the fact that it is more secure than basic authentication because we are actually hashing credentials instead of using plain text, and the passwords are not directly exposed in this case. But the number one disadvantage is that there is cost of time and resources when you want to actually validate that particular credential that is being sent back to the server, and the server do not still have any way of ending the user session, which brings us to cookie based authentication. Now, this was the OG authentication approach on the web. I think even the first time I ever wrote a server side code and was thinking about authentication, I was hearing about things like cookies. So firstly, what exactly is a cookie? Well, you can think of a cookie as anything. It can basically be anything. It can be a number, a string, it can be a serialized object, and so on, which is sent from the server to the client to be saved on the browser. And it should be noted that for security reasons, this is usually encrypted. So how does cookie-based authentication works? Well, after logging in, the server issues an encrypted cookie. Now, this cookie is like a magic key that is sent with every request. Now, the HTTP request looks something like this. Now, let's look at the steps involved. Well, the user enters the login and password, like with the previous authentication mechanism, and then the server is going to validate the credentials and is going to return or issue an encrypted cookie. And afterwards, the user's browser is going to store the cookie, and the cookie is going to be sent with each request. Now, for every request that is sent to the server is going to check the cookie and is going to verify the cookie. So it looks something like this from the client to the server, from the server back to the client with a cookie return, and then for every request there's a cookie sent, and then the server sends an appropriate response back. Now let's look at the pros and cons. Well, the first advantage is that it is encrypted and it is self-contained. Another is that cookies are stateless and they have inbuilt browser support. So all browsers by default support cookies. Yeah, give me a cookie. And then there is easy session management and revocation on the server. Let's look at the number one disadvantage of this particular method. Well, this is sent with every request, which in some cases can actually slow things down. And then the one which I can argue is the biggest disadvantage is the fact that this is only limited to browsers. So if you are working with mobile app, well, sorry, you might have to look for or think of another authentication mechanism. And then thirdly, it doesn't really scale well, which brings us to session-based authentication. Now, this is very similar to cookie-based authentication, except for the fact that there is now a session ID involved instead of any other encrypted data that might have been issued in the cookie. And an example looks something like this. We can still use this with a cookie and send a cookie, and the cookie actually contains the session ID for that particular user. Now, let's look at the steps. It goes like this. When the user logs in, the server is going to validate their credential, create a token, save it inside of the database. Now, that particular session that is created, the session ID is issued as a cookie. Now, once the browser gets it, it's going to actually save that cookie in the browser. And then, just like with the cookie-based authentication, for every request, the cookie is going to be sent, and the server is going to retrieve the session data using the session ID and retrieve the session data from the database. So the overview goes like this: from login to the server, and then a success response with the session ID usually sent and stored inside of a cookie. And then for every request, that same cookie with the session ID contained is going to be sent to the server, and the server is going to send the appropriate response back. Now, let's quickly look at the pros and cons. Well, number one, sensitive data is going to be stored on the server side. So even when you look at the cookie, well, you don't get any sensitive data of the user on the client side. Well, the number two advantage is the fact that there is a centralized control for security features right on the server. And then there's also the advantage of cross-domain communication. Now, let's look at the disadvantages of this auth method. Well, firstly, it requires DB call for validation. So say I to latency there. This is limited to browsers only. And there is also scaling issues when it comes to distributed databases. So let's say you're making use of different databases, or let's say you're making use of something like a microservice architecture. Well, there are going to be some issues with this particular approach. Which brings us to our next authentication mechanism we want to look at, which is token-based authentication. Now, the way this works is after login, the server is going to issue a token. Now, this is like a badge for the clients to use to identify themselves. Same way, when you go to an organization and you're given a badge, well, that particular organization is going to identify you and know who you are by seeing that your badge. So it's similar to session authentication, except in this case, there is no cookie involved. And then that particular session ID we add when it came to session authentication is going to be replaced by a unique string that is going to be generated by the server. And an example of the request looks something like this. Now, let's quickly go over the steps. Well, the user logs in as usual, and then the server is going to validate that particular credential the client sent and create a session. But then a token is going to be issued, and that token is going to be stored on the client side. Now, the token is going to be sent every time there is a new request, and the server is going to verify the token. A high-level overview of that looks something like this. Now, let's quickly look at the pros and cons. Well, the number one pro is the fact that it works on any device. So, whether your finance app actually has a mobile application or a desktop application doesn't really matter or isn't really an hindrance, because this method is going to work. And it also supports distributed architecture, and also no credentials is going to be exposed in the token, which is awesome. Now let's look at the cons. Well, firstly, there is no built-in client support. So you have to get ready to code. Unlike cookies, which are natively supported by browser, well, this isn't natively supported by browser, and you have to find a way to store that particular data maybe in a state and find a way to persist them and to send them across for every request. Now, storing of the token on the client side can be insecure, and the third disadvantage is the fact that, well, database calls is required for validation, in which there is a performance hit. So the token that is generated and being sent to the client is going to be stored somewhere. So that automatically means whenever the client makes a request to the server has to look through the database, and check which user does this particular token belongs to. Okay, this is the user, and then validate that particular request. Well, to take care of issues like this, that is why we have JWT Authentication or JWT tokens. Well, JWT or JSON Web Tokens are just a type of tokens that are self-contained, and the way it basically works is the server issues a self-contained token that includes the necessary data validating that particular user, which reduces the need for database lookup. So it's more of like a Swiss Army knife of tokens. And an example of the request looks like this. So we have a bearer in front and then followed by the token, the JWT token. Now, the steps involved looks something like this. The user's login, and then the server is going to validate the credential and then issue a JWT token. Note that this is usually not stored inside of the database, but JWTs are meant to be signed by a unique key, which only the server should be able to identify. So if a wrong JWT token is being sent to the server, well, the server is going to verify with the unique key, and if it does not match or there's an error, the request is going to be invalidated. So the token is stored on the client side and is sent with each request, and the server is going to verify the token's signature. A high-level overview looks something like this. Now, let's quickly look at the pros and cons of using JWT token authentication. Well, firstly, they are self-contained and they are stateless. Okay, they have high performance since there's no need to do any database lookup, and there's cross-domain and device interoperability. So that means it doesn't matter what the client is, whether it's a web app, a mobile app, a desktop app, and so on. JWT token is going to still be an awesome or a nice choice. Now let's quickly look at the cons. Well, there is risk of token hijacking. So that means in this case, you have to think of ways in which you are going to secure these tokens. And some of the popular and recommended ways are things like make sure their expiry dates are not too long, use mechanisms like having refresh tokens, and so on. The second disadvantage is the fact that there is no built-in session revocation, and then there's also risk of exposing sensitive data. Given the fact that JWTs usually contain a payload, which are usually information pertaining to the user. Now, let's look at API key authentication. Now, this is not usually used for user authentication, but commonly used for, let's say, third-party integration or API integration or machine-to-machine communication. So how it works is there's going to be pre-generated keys which are to be used for this type of communication. So it's more or less like a guest pass for your application. So users register on your application, well, they have a kind of dashboard in which they can create or generate API keys, and they're going to use these API keys for authentication. So that way on your server you can determine things like, okay, who exactly is this user, okay, what access do they have on the API, is there a kind of limit to their usage, and so on. And the HTTP request looks something like this. Let's quickly look at the steps. Well, the API key is generated beforehand. This is not usually when a user logs in, but like I mentioned earlier, usually generated on a specific dashboard. Now, the client includes the API key for every request, and the server verifies the API key. Now, let's look at the pros and cons. Well, for the pro, it is simple for machine-to-machine communication, and it's also easy to generate and use. But let's look at the cons. The first one is there's security concerns when it comes to the storage. So that means some clients or some users might actually be careless with it. And usually there is no expiration unless it is revoked manually. So there we have it. Choosing the right authentication method depends on your app needs. And don't be afraid to actually mix and match any of these authentication mechanisms for best security. Remember that the goal is to keep your app secure without driving yourself crazy. So let me know, are there any other type of authentication method mechanism you actually like me to talk about, maybe OAuth 2, and so on? Please feel free to leave a comment below. And also regarding your thoughts on this video, don't forget to like, share, and subscribe, and I'm going to see you in the next one. Thank you for watching.